Okay, so welcome to week one of Philosophy 371, 473, or 671, whichever class you're enrolled in. And we get to start this semester off by complaining about classical logic. So we get to start this semester off by complaining about some of the things that we didn't like or that we found unintuitive or confusing about whatever logic it was that you've already taken. So I'm not sure what logic class that was, but chances are you've seen at least some of these ideas before. So before we go into that, we're going to talk a little bit about formal systems generally. So when you've got a formal system, so something like sentential logic or first order logic, or some kind of system where the goal is to take, maybe natural language or something less precise and make it precise, we end up with these trade-offs between complexity and expressive power. So for example, you might remember whenever it was that you went from sentential or propositional logic, so that's logic with no quantifiers, to logic where you did have quantifiers, so logic where you have a universal and an existential quantifier. So some things you noticed were the fact that everything was more complicated all of a sudden. There were these variables to keep track of, brackets were more complicated, there were these extra distinctions, so there was more complexity. But there was also more expressive power because you could say things. So you could now express general statements. So for example, if I said, all dogs are fuzzy, Beezy is a dog, therefore Beezy is fuzzy, there's actually no way to represent that as a kind of valid argument that preserves its internal structure. You can't really do that in propositional logic, but you can do that in first order logic. So we have more expressive power because I can actually express those claims all together and show that they're a nice valid argument. So there's where we end up trying to figure out what a good balance might be. So if you're actually trying to figure out what formal tool you want to use for a particular purpose, then that's one of the things that you need to think about. So when we start off with something like truth functional logic, so that's a logic where you got to use truth tables. So you got to basically just calculate truth values, so trues and falses or ones and zeros, just based on earlier ones. Now they're great, right? Truth tables are great. They're fun. They're not super difficult. So once you get the rules, there's not really a lot to them, right? You don't need a lot of insight. You just need to be careful and you need to follow the rules. So they're great. But now you might want to ask yourself, like, what complexity do you give up, right? So given that they're nice and simple, what are some of the things that you can't express? So what are some of the subtleties about natural language that you don't get because you get the simplicity of truth tables? So let's talk about a couple of things. So first of all, we have this conjunction, okay? So you might have a conjunction like A and B, okay? So you might say, well, is this always equivalent to B and A? Now, if you're just building truth tables, if you're just in the constraints of truth table logic, then the answer is yes, obviously. The two make logically equivalent claims. But on the other hand, if you think about this in the context of some things that you might say in ordinary English, they might not seem so obviously equivalent. So if I say the first sentence, if I say Scooter sat down and got a treat, she's outside the door right now, but don't worry, she'll get a treat later. So Scooter sat down and got a treat versus Scooter got a treat and sat down. Now, in some sense, I'm still saying that two things happened, but one thing that you might hear when you hear me say those two things is you might hear a different temporal order. Okay, so they might imply different scenarios. You might picture different things in your head, but the difference between those two scenarios is going to be lost as soon as you symbolize it using the conjunction symbol in formal logic. Okay, so that's something that you lose because you have the simplicity of truth tables. And now, the truth table for conditional. Okay, so this is the truth table for what we call the material conditional, or the arrow. You might have seen it using a slightly different symbol, like a horseshoe sometimes. But, the basic rule is that the conditional is only false when the antecedent is true and the consequent is false. And lots of people find that incredibly unintuitive. Right? There's some interpretations under which that might seem natural, but there's also lots of interpretations where that might seem super unintuitive, right? So, for example, here is a true material conditional. If Scooter was a houseplant, then Audrey would be one too. So why is that a true conditional? Because the antecedent and the consequent are both false, right? Neither of us are houseplants, you may have noticed. So false, arrow false, that's true. So it's a true conditional, but it might seem like a really weird statement to call true. Okay, so there's another feature. But on the other hand, you know, just because that seems unintuitive, you got to make a decision. So every sentence with a false antecedent and a false consequent has to end up with the same truth value if you're going to use truth tables. So basically, you have to decide. Just because some instances of the conditional seem intuitive and some instances of it don't, if you're going to use the truth table method, you don't get to say one is true and the other one's false. That's just not how truth tables work. So that's something that you give up if you want to use truth tables in classical logic. Okay, so there's a few features about the propositional connectives, so the truth tables for the propositional or sentential connectives, that you might have found counterintuitive. You might want to complain about them. Another thing that you might want to complain about is the definition of validity. So the definition of validity that maybe it was me, maybe it was somebody else, probably drummed into your head during your very first intro logic class, right? So we probably said this a lot. I say this a lot in my life. So I say something like, an argument is valid when there is no case in which the premises are all true and the conclusion is false. So it's not possible for the premises to be true and the conclusion to be false. Okay, so valid or invalid. Okay, let's look at an argument. Let's see if it's valid. Richard is Austrian, but Richard is not Austrian, therefore the earth is flat. Well, is there any case where the premises are both true and the conclusion is false? Is there any case where Richard is Austrian and not Austrian? You know, doesn't really seem right. It's like one's the opposite of the other. So where something's true and false at the same time. So I'm making two conflicting claims about Richard, and so what that means is that the premises can't be true at the same time. So that means that there's no possible way to have true premises and a false conclusion. So this argument's valid. Okay? Even though the conclusion says the earth is flat, even though the premises and the conclusion don't have anything to do with each other, I still say the argument's valid because it fits the definition of validity. And you might think that that's super weird. You would be right if you thought that that was a super weird consequence of the definition of validity in classical logic. So feel free to complain about that. Okay, so if you're going to complain, though, you got to go past it, right? You got to do something about it. So, you know, complaining is one thing, but in this class, what we're going to do is we're going to talk about how to find solutions, or at least some potential solutions for some of those complaints. And the solutions are to go beyond classical logic, so to go to non-classical logics. But one thing that we want to mention right away is that there's actually two different ways to do this. So there's kind of two responses that you might have to a complaint about classical logic. One response is to give an extension of classical logic. So to say, okay, classical logic, you're fine, but you just don't go far enough. Okay, so there's just some things which you don't capture, but I'm just going to add something to classical logic. So that's a little bit more in the spirit of adding quantifiers to propositional logic. So you add something, but you don't mess with anything that you had before. Another option would be to suggest an alternative. So basically you scrap something that there was in classical logic and you replace it with something else. Okay. So some extensions of classical logic that we're going to look at. So these are approaches that add new operators or new mechanisms to classical logic. So ones like that we're going to see different kinds of modal logics, or logics that represent intentional features of language. That's not a typo. We'll talk about it a little bit more later. But modal logic and epistemic logic, those are going to be extensions of classical logic. So those are going to be ways that we can represent further features of claims, of propositions, of language, maybe, however you want to think about that. Right now, it's okay. They're going to represent further things that classical logic can't do. But they're not going to conflict with anything that happens in classical logic. So they're not going to contradict classical logic. Okay? That's the job of alternatives to classical logic. So those are approaches which will reject and replace some features or some mechanisms of classical logic. So for example, you might find some logics, we'll see some logics that reject the assumption that every sentence is either true or false. So you might have some sentences which are neither. We can add more truth values. So it doesn't just have to be true or false. You might have a truth value that says neither. You might have a truth value that says both. Okay, you might have degrees of truth and falsity. That's a possible way that you could design a logic. So, related to that idea, you reject the assumption that a sentence is not allowed to be both true and false. Okay, so under certain kinds of logics, you can have overloaded truth values for a sentence. So a sentence can be assigned true, can also be assigned false, and that's okay. Right? It's definitely not okay in classical logic, but there are some logics where that's fine and where that makes sense, and it's just part of the mechanism. You can reinterpret some of the logical operators. So you can reinterpret the conditional. Okay, so you can reinterpret the conditional so that it's not given a truth table definition, it's given some other kind of definition. Okay, and then it'll work differently, so you symbolize it differently. And you can reject the idea that an argument that has inconsistent premises is valid, so you can redefine what validity means in your system. And there's also going to be a bunch of different ways to do that. So with all of these different approaches, there's tons of ways to revamp classical logic. And a lot of them are motivated by some kind of thing that you might find unintuitive or weird or just unsatisfying or incomplete about classical logic. So that's basically the kind of thing that we're just going to talk about during this first week, is what you have seen in logic so far that you want to improve on. So the whole motivation for non-classical systems is to be able to improve on existing features of classical logic. So that was just a little bit of a quick tour through some of the basic motivations. So why complaining about logic is actually a perfectly good thing for us to do right now, and also at some points in the future. So I will talk to you all soon.